This incredible creature lived during the late Carboniferous period, a time when Earth's atmosphere was rich in oxygen, and the planet was teeming with bizarre and oversized creatures. With a length stretching over 2.5 meters, 8 feet, Arthropleura dominated the forest floor. But how did this colossal millipede thrive in a world so different from ours today? What did it eat, and why did such a giant insect go extinct? Stick around as we dive into the life and mysteries of this prehistoric titan. During the Carboniferous period, Earth was a very different place. Dense forests covered the land, and giant trees, ferns, and horsetails dominated the landscape. The atmosphere contained significantly more oxygen, up to 35% compared to the 21% we have today. This abundance of oxygen not only fueled the massive size of creatures like Arthropleura, but also allowed for the existence of enormous insects and arthropods. Arthropleura made its home in these moist, humid forests, where it slithered across the forest floor, feeding on decaying plant material. Despite its fearsome appearance, this giant millipede was likely herbivorous, sustaining itself on the rich, dense foliage of the Carboniferous forests. So what made Arthropleura so enormous? Its body was divided into dozens of armored segments, each equipped with pairs of legs, allowing it to move swiftly through its environment. These hard plates not only protected it from potential predators, but also helped it glide smoothly across the forest floor, much like modern-day millipedes. But unlike today's millipedes, Arthropleura didn't have to worry about large carnivores. Its sheer size was its greatest defense. In the shadowy depths of ancient Carboniferous forests, prehistoric giant to disappear the undergrowth. As the Carboniferous period came to an resembling a millipede, the planet's climate began to change, thrived in the moist, humid ecosystem, and the forest that once stretched endlessly across the land began to flow like a river over the damp earth. Along with this, navigating oxygen levels started to decline, belied its size, making it harder for giant arthropods like Arthropleura to survive vegetation, providing an abundant food source for this fascinating creature. Shrinking habitats and reduced oxygen levels was a lush paradise, led to the extinction of the sun's rays and many other oversized creatures of the time, casting dappled light upon the ground below. The Carboniferous period, greens of lasting from about 359 to 299 provided a textured carpet for its time of remarkable change in the shadows, pulpy leaves, and decomposing vastly scattered creature acting as a dense late Carboniferous or towering trees, a time when the stillness was rich in oxygen wires. The crunch of plant material under its many oversized storage of a creature well adapted to its environment, stretching over 2.5 fearsome paradise. Arthropleura dominated the forest as one might imagine. But how did this colossal its anatomy seems to tell a central tale from ours was one of a creature more aligned with a peaceful levels of a giant lifestyle go extinct. The powerful, robust jaws were perfectly suited for grinding mystery fibrous plant matter titan. A stark contrast to our current atmosphere played a crucial role in the ecosystem, oxygen, aiding in the decomposition process and enriching the soil. Life into colossal creatures. Its presence helped maintain the delicate sizes of dense foliage around ecosystems, binding the interconnected web of life together, fostering an abundance size of Arthropleura, starkly contrasts with today's provided both shelter and curiosity and awe, creating a flourishing ecosystem. Living alongside other ancient beasts, among these imposing denizens was the dynamic ecosystem where flora flourished, a giant millipede-like creature formed the foundation of life to 8 feet. Envision storms raged and seasons through the underbrush of this giant millipede adapted and survived, pushing aside ferns, navigating the challenges of its environment with an unmatched colossal arthropod epitomized the extraordinary size that organisms could achieve when supplied with ample oxygen. Arthropleura was one of the most remarkable inhabitants, dragonflies with wingspans reaching nearly 2 feet. We look back at Arthropleura not just as a relic of the past, bodies glinting, but as a representation of the wonders of evolution. The abundance of carbon-rich plant bones, which is now transformed into coal deposits, are a reminder of a time when giants roamed the planet's climate and atmosphere, roaming among thick shafts of sunlight and decayed. Each buried beneath layers history of our planet, effectively trapping us carbon. Even the most fearsome creatures were once geological giants, silently contributing to the cycle of decomposition, where life and death intertwined, creating a delicate balance that would impact the evolution of life for millions of years to come. As the Carboniferous period drew to a close, its legacy lingered. The unique conditions that allowed for such biodiverse ecosystems paved the way for the emergence of new species and the eventual dominance of reptiles. This period's remarkable flora and fauna not only shaped the history of life but also left an indelible mark on the Earth's geology and atmosphere, setting the stage for the various evolutionary paths that followed. During the Carboniferous period, Earth transformed into a lush green paradise, where dense forests intertwined with towering trees, creating a vibrant tapestry of life. Giant ferns and thick horsetails swayed gently, their presence a silent testament to the rich biodiversity that flourished in this verdant epoch. The warmth of the climate embraced the landscape, fostering a habitat that thrived beneath a dynamic sky, painting a picture of a world far removed from our modern environment. The atmosphere during this time was laden with an extraordinary amount of oxygen, soaring as high as 35%. This elevated oxygen level created an ideal breeding ground for life, allowing creatures to grow to astonishing sizes. Among them, the fearsome Arthropleura, a giant millipede, roamed the ancient forests, its segmented body stretching longer than a human. The sheer presence of such colossal beings illustrated the profound impact of the surrounding environment on the evolutionary pathways of species. Moreover, the abundance of oxygen catalyzed the emergence of enormous insects and arthropods, some of which could achieve wingspans exceeding that of modern birds. Imagine dragonflies with wings as wide as your arm, soaring through a humid sky, their iridescent bodies catching the sunlight. The air was alive with a cacophony of insect sounds, echoing through the lush foliage, a reminder of the thriving ecosystem that flourished in this time. As the dense forests developed, they played a crucial role in shaping the Earth's climate and geology. The vast vegetation absorbed carbon dioxide, contributing to a stable climate while reinforcing soil structure. This large-scale growth meant that life thrived not only on land but also in the water, as the recycling of nutrients created rich habitats for amphibious creatures. The legacy of the Carboniferous period lives on through the fossilized remains that can be found buried in the rocks. What once was a world adorned with towering trees and colossal creatures now lies as a reminder of the Earth's ever-changing nature. Understanding this time helps us appreciate the delicate balance of ecosystems and the importance of oxygen-rich environments for growth and survival. As we marvel at the remnants of the past, we reflect on how ancient Earth shaped the path for life as we know it today. The Carboniferous period was a time of remarkable biodiversity, where towering plants and colossal arthropods, such as Arthropleura, ruled the lush landscapes. Imagine a world blanketed in dense forests, where moisture hung thick in the air, enabling the growth of these enormous creatures. This era presented an environment teeming with life, where giant millipedes could flourish in the rich undergrowth, reaching lengths over 8 feet. As the Carboniferous period waned, however, a dramatic shift began to unfold, unraveling the tapestry of this thriving ecosystem. Evolving climatic conditions marked the beginning of the end for these prehistoric giants. Climate change initiated a transformation of the planet, and thriving swamps that once cradled their existence were drying up. Picture vast stretches of verdant marshland giving way to arid landscapes, with golden sunlight piercing through the thinning tree canopies. The gradual disappearance of these water-permeated environments signified an escalating crisis, pushing Arthropleura and its kin to the brink of survival. Oxygen levels began to decline, and the very breath that nourished these vibrant creatures was being withdrawn. During the Carboniferous period, oxygen levels soared, fostering the growth of massive organisms. However, as time progressed, the atmosphere shifted. Consider a world where each inhalation becomes a struggle, where each labored breath carries the weight of an impending extinction. Giant arthropods, once the titans of their epoch, now struggled to find their footing in the changing landscape, fighting against not only their diminishing habitat but also depleting atmospheric conditions. As forests retreated and swamps evaporated, food sources diminished, leading to competition and starvation among species. Picture the once abundant feast of decaying plant matter now dwindling into an elusive prize, a mere shadow of its former bounty. The interplay of environmental factors and changing ecological dynamics spelled disaster for these magnificent creatures. As the Carboniferous period drew to a close, The final curtain began to fall on Arthropleura and its relatives, marking an epoch where giants no longer roamed the earth. The narrative of survival and adaptation transformed into one of loss and extinction, heralding the end of an extraordinary era. Arthropleura, an ancient giant of the Carboniferous period, astounds paleontologists with its colossal size, reaching lengths of up to 2.5 meters. This impressive scale is attributed to a myriad of evolutionary advantages that set it apart from its modern relatives. Understanding the reasons behind its immense size offers a fascinating glimpse into the ecological conditions of prehistoric Earth. The body of Arthropleura was segmented into dozens of armored plates, a design that provided both protection and mobility. Each segment bore a pair of legs, enhancing its ability to traverse various terrains with surprising agility. Much like a modern-day millipede, these multi-legged structures allowed it to glide over the damp forest floors teeming with foliage. The well-developed legs worked in unison, creating a rhythmic movement that ensured efficient locomotion through dense vegetation. One of the most striking aspects of Arthropleura's existence was its lack of formidable predators. Unlike today's millipedes, which must navigate a world filled with carnivorous threats, Arthropleura flourished in an era devoid of large terrestrial carnivores. Thus, its sheer size became a pivotal defense mechanism. This colossal creature could intimidate potential threats, while its armored segments acted as natural shields against any would-be attackers. The environmental conditions of the Carboniferous period played a crucial role in enabling such gigantic forms to evolve. Dense forests, abundant moisture, and high levels of atmospheric oxygen created an ideal habitat for large arthropods to thrive. With oxygen levels reaching up to 35%, respiration became much more efficient, empowering organisms like Arthropleura to grow larger than what we see in today's ecosystems. This interplay of biology and environment laid the groundwork for its impressive stature. In exploring the marvels of Arthropleura, it's essential to consider the interconnectedness of size and ecological role during its time. This giant not only dominated its surroundings, but also influenced the dynamics of the ecosystems it inhabited. As a significant detritivore, it contributed to the breakdown of organic matter, playing a vital role in nutrient recycling and helping sustain the lush forests that nourished a diverse array of life. It's a clear reminder of how evolutionary paths can lead to extraordinary adaptations in response to specific environmental circumstances. In the waning days of the Carboniferous period, the Earth was a lush paradise dominated by sprawling swamps and towering forests, where giants roamed freely. Among them was the gargantuan Arthropleura, a colossal millipede-like creature that thrived in this verdant world. As the climate shifted at the end of this era, the once familiar landscape began its dramatic transformation, leading to a tale of survival challenged by nature's changes. As the climate turned, the swamps that had provided refuge and sustenance gradually dried up. The lush greenery that once blanketed the terrain began to recede, leaving behind desolate patches of earth. The vast forests, which had been the lungs of the planet, diminished, casting shadows of uncertainty over the colossal Arthropleura. With fewer places to thrive, these majestic arthropods faced an escalating struggle against their new reality. Simultaneously, a gradual decline in oxygen levels compounded their plight. This once abundant resource, crucial for the survival of many species, experienced a remarkable drop. For creatures that had grown accustomed to breathing in a rich oxygen environment, these changes became catastrophic. The very essence required for their survival began to dwindle, compressing their ability to thrive and reproduce. As Arthropleura grappled with these challenges, their fate hung in the balance, teetering on the edge of extinction. The combined pressures of shrinking habitats and reduced oxygen availability created a perfect storm of adversity. Arthropleura, unable to adapt quickly enough to this rapidly transforming ecosystem, became increasingly isolated. Other oversized organisms of the era faced similar fates, dwindling numbers echoing the overarching narrative of extinction. The vast forests once filled with life fell silent, a hushed witness to the collapse of an ecosystem. Ultimately, the disappearance of Arthropleura marked a poignant chapter in Earth's history, symbolizing the intricate dance of survival amidst environmental upheaval. As the Carboniferous period drew to a close, the world as it had been known transformed into something starkly different. The legacy of these prehistoric giants fades into obscurity, yet their story remains an enduring reminder of the delicate balance between life and the planet's ever-changing nature. In their extinction, they leave behind whispers of resilience, adaptation, and the haunting inevitability of change. Imagine a world where nature's giants roamed freely, where towering forests stretched endlessly and colossal creatures dominated the landscape. This is the spellbinding era of Arthropleura, a titan of the Paleozoic, whose sheer size and presence continue to captivate our imaginations. Measuring up to 2.5 meters in length, these ancient arthropods resembled oversized millipedes, announcing their existence in a time before dinosaurs ruled the earth. They walked the primordial stages of life, encapsulating an era of unexplored evolution and the grandeur of biodiversity. As we delve deeper into the world Arthropleura inhabited, lush, humid environments come to life, teeming with primitive plants and diverse life forms. Envision a dense canopy filtering sunlight, casting dappled shadows on the forest floor. This was a time when the air was rich with the scent of decaying vegetation, and the sounds of thriving ecosystems echoed around nearly every corner. Meanwhile, mighty Arthropleura glided through the underbrush, its segmented body undulating gracefully, demonstrating nature's artistry in an era far removed from our own. But what led to the extinction of such an awe-inspiring creature? While the world of Arthropleura was thriving, it faced challenges such as climate shifts and changes in Earth's geography. As plant life evolved, so too did the creatures reliant on it for survival. Arthropleura's story is a testament to nature's ever-changing dynamics, reminding us that survival is often dependent on adaptability. This incredible creature lived during the late Carboniferous over 290 million years ago. Earth's atmosphere was rich in oxygen, continues to foster curiosity and exploration among modern scientists and enthusiasts alike. With a length stretching over 2.5 has captured your interest, 8 feet, there is much more dominated the forest floor. But how did this colossal fossilized remnants of this extraordinary creature stir a sense of wonder? What did it illuminating the extensive tapestry of Earth's history go extinct? From the depths of ancient seas around as we dive into the life and mysteries of this prehistoric to these remnants of life long gone. To keep unearthing such fascinating insights, we encourage you to embrace the adventure. Like, subscribe, and hit the bell icon to join us on more thrilling journeys into Earth's ancient past. Together, we'll continue exploring the wild and unpredictable tales of our planet's formidable history. Imagine a world where survival depended not just on size or speed, but on an impenetrable shield. From spiked tails to hardened shells, these armored giants roamed the ancient world, warding off some of the most fearsome predators ever to live, ready to meet the prehistoric tanks that dominated the landscape. In a time when survival meant being stronger, faster, or deadlier than your opponent, some creatures developed a different approach: armored, unyielding, nearly indestructible. From the clubbed-tail Ankylosaurus to the armored Glyptodon and prehistoric turtles, these titans of defense dominated their ecosystems. Evolution is the ultimate game of survival, and some creatures chose to turn themselves into living fortresses. But why armor up? In a prehistoric world filled with aggressive carnivores, armor was a strategy that turned prey into a formidable challenge. From thick plates to spiked tails, these creatures developed unique tools to protect themselves. Meet Ankylosaurus, one of the most well-armored dinosaurs to ever exist. Living during the late Cretaceous period, this 30-foot-long herbivore was built like a tank. Its body was covered in bony plates, known as osteoderms, which acted as a protective shield. But its real weapon? That massive clubbed tail. Swinging with enough force to break bones, Ankylosaurus could defend itself against even the most formidable predators like T-Rex. A creature so well-armored that even the king of the dinosaurs had to think twice before attacking. Now let's travel forward in time to the Ice Age, where another armored creature roamed, the Glyptodon. This mammal, closely related to modern armadillos, grew up to 10 feet long and weighed over a ton. Its defining feature? A massive dome-shaped shell. Like Ankylosaurus, Glyptodon had a defensive weapon, but in this case it was its entire body. With a shell as thick as bone, it was nearly impenetrable to predators. Even the most determined Ice Age carnivores had trouble cracking this prehistoric tank. Let's dive underwater and meet some of the earliest armored creatures. Prehistoric turtles. While today's turtles are well known for their protective shells, their ancient relatives were even more formidable. Take Archelon, for example. This colossal sea turtle had a shell that spanned over 13 feet, and its broad, flat body made it one of the most imposing creatures of the ancient seas. Its armor helped protect it from predators like mosasaurs and sharks. So why was armor such a successful strategy for these prehistoric giants? The answer lies in biology. Armored animals have evolved multiple times across different species because protection is universal. Whether on land or in the sea, being well protected means surviving longer, reproducing more, and ultimately outlasting the competition. Life as an armored dinosaur wasn't easy. These massive creatures faced numerous challenges in their environments. Imagine roaming the ancient landscapes, constantly on the lookout for predators lurking in the shadows, ready to strike at any moment. The threat of attack was ever present, and these gentle giants had to be prepared to defend themselves at all times. On top of that, they had to cope with the ever-changing climate, which brought about extreme weather conditions, from scorching heat to freezing cold. Despite these challenges, armored dinosaurs thrived, and their ability to adapt was key to their survival. Another challenge they faced was finding food and resources in a world where competition was fierce. They had to be clever and resourceful to get by. One of the most significant challenges armored dinosaurs faced was their own size. Being massive has its advantages, but it also brings its own set of problems. It's harder to move quickly, and you need a lot of food to sustain yourself. This meant that they had to be extremely efficient in their daily lives, using as little energy as possible to get by. So, how did these incredible creatures overcome these challenges and thrive in their environments? Delving into specific examples of armored dinosaurs, we find some truly remarkable creatures. Take Ankylosaurus, for instance. This dinosaur was a walking tank, with thick, armored skin covering its body, and a club-like tail that it used to defend itself. Ankylosaurus was a herbivore, but it was no pushover. It could easily take down a predator if it felt threatened. Another armored giant was Stegosaurus, which had a distinctive row of plates running down its back, providing protection from predators. But these plates didn't just offer defense, they also helped Stegosaurus regulate its body temperature, making it a highly efficient creature. Stegosaurus and Ankylosaurus were both incredibly successful in their time, and their unique defenses played a huge role in their survival. But what made them so special, and how did they develop these remarkable adaptations? One of the key factors was their armor. Each species had its own unique armor, tailored to its specific needs and environment. Ankylosaurus's armor was thick and heavy, perfect for defending against the massive predators of the Cretaceous period. On the other hand, Stegosaurus's armor was lighter and more agile, allowing it to move quickly and easily. As we explore the world of armored dinosaurs, we're constantly uncovering new and astonishing discoveries that shed light on their behavior and interactions with their surroundings. One of the most remarkable discoveries is the evidence of armored dinosaurs engaging in complex social behaviors. For example, some species of Ankylosaurus have been found with injuries that suggest they were attacked by other ankylosaurs, but instead of being killed, they were cared for by their herd. This level of social complexity is rarely seen in the prehistoric world, and it's a fascinating insight into the lives of these incredible creatures. But that's not all. We've also discovered evidence of armored dinosaurs migrating across vast distances, following ancient routes that were likely used by their ancestors. This level of organization and coordination is incredible, and it speaks to the intelligence and adaptability of these remarkable animals. As we continue to study these incredible creatures, we're constantly amazed by their complexity and sophistication. So, what made these armored titans successful in their time, and what can we learn from them? At the heart of their success was their ability to adapt to their environments, using their unique defenses and survival strategies to thrive in a challenging world. They were incredibly resilient, able to withstand the test of time and overcome the many obstacles that stood in their way. And as we look back on their achievements, we can't help but be inspired by their tenacity and determination. Thanks for joining me on this journey into the prehistoric world. I hope you've enjoyed learning about these incredible armored titans. If you've got a favorite armored dinosaur, let me know in the comments below. And don't forget to check out my other videos for more intriguing prehistoric insights. Until next time, stay curious.